Hey everybody, welcome to topic 1.4, finding limits from tables. So today, the title tells us all. We're going to find limits from tables. Either they're going to give us a table or we have to come up with a couple of values to plug into our calculator, and we'll show you how to do that. So we'll often have to find limits from functions without the aid of a graph. Okay, we'll get into how to calculate limits algebraically coming up, and that's our next big topic. But for now, we've learned about graphing, and now we're going to learn how to estimate the limit from a table of values. So let's consider the example here. According to the table, what is the value as the limit approaches -4? So remember, there is no plus or minus here, so we have to consider from the right and the left. And you can see, in this case, I put a bar down the middle. I'm getting close to -4 here, and I've got to think about coming from the right, numbers that are larger than -4, and also coming from the left when values are less than -4. So what is, as x approaches -4, let's take a look at what our y's are approaching here. Okay, and you can see that although they're different, they're not that different. You've got 2.499 and 2.5. So it's safe to say the limit as x is approaching -4 of our function is 2.5. That's the limit. And that's how we can estimate from a table. In example 2 here, they give us a function. And they say, given f of x equals x minus 3 over x minus 2, and we know that x cannot be 2 here, we're undefined. Okay, use a table to create the values, and we want to approach 4. So how do we do that? Now, again, I put these double arrows in just for help. But how do we start that? How many numbers do we choose? Well, when we do this, we might want to start with a value like 3.9. That's close. Well, let's get even closer. How about 3.99? So those are kind of numbers I'm looking at from the left of 4. And how about 3.999? Okay. Now what we can do is we can plug each of those values, 3.9, into that numerator, right? And simplify, but that gets tedious. So I'm going to put a link up above to show you a quick way on how to calculate all these values using your TI-84. So I encourage you to click the link above, and I'll put the link in the description. But when I plug each of those values into our function, these are the values that I get. So from the left of 4, coming from 1, 2, 3, from the left of 4, it looks like we're approaching 1/2. So now we need to figure out, well, what are numbers that are really close to 4, but not quite 4? So how about 4.001, 4.01, and maybe 4.1? Now those are good values to use across the board when they ask you to create your own table, the 99s and the .001s. So I encourage you to kind of look at that table and think about that for problems that you'll see later on. When I plug each of those into my calculator, again, look for that tutorial if you don't know how to use your graphing calculator to help you simplify. I get the following values. And so because these numbers, it looks like, again, they're both approaching the same number from the left or right, our limit exists. And it appears that that limit as we approach, the limit as we approach 4 of our function, you could write the function, I'll just put fx, is 1/2. Okay? And this is a short lesson. This is our final problem. The table below gives us a value of a function, f, at selected values of x. Which of the following conclusions can be made? So let's look at what's going on here. As I'm cruising this way from the left, I'm getting really close to the value of 3, 2.9, 2.99. And from the left, from the right, I'm also approaching 3. See how the numbers are getting closer to 3? So the conclusion here that they want us to look at is, hey, what's going on with your f of x values, your y values? And you can see here as I get towards the middle, they're the same number, just opposite signs. So from the left and from the right, our limits don't match. So basically, as we approach 3 from the left, we're approaching 1,000, probably going to infinity, 10, 100, 1,000. But as we approach 3 from the right, we're going in down to negative 1,000, or 1,000, excuse me. Those numbers don't match. Because the left and right hand limits don't match, the limit at 3 does not exist. So if you have any questions or comments about any of these 3 examples please type them below. You can go ahead and check out the practice problems and the AP type problems. I'll include a solution key on the website. So this is Nicholas Jamv, and we'll see you next time for topic 1.5.